So mobility challenges and mitigation strategies. Challenges and mitigation strategies. Uh, so mobility signaling latency. It will fix. So conditional handovers, faster handovers, and reduced failures. This will fix this mobility signaling latency, and then proactive handovers with distance D1, D2, which I'll be covering in the next slides, and timing based, event based with a timer that will also solve cell footprint and signal variation. And ratchless handover, which will eliminate the ratch procedure and reduces the overhead, which will solve the challenge of high volume of handovers. So conditional handovers, it is enhanced NTN triggering mechanism. UV will activate the handover automatically when specific preset triggering conditions are met. So ratchless handover, it is procedure during handover saving time and signaling. So source cell, it will give pre-calculated timing advance to the user equipment, and user equipment syncs uplink transmission to target satellite using timing advance. So target cell provides grant for initial uplink transmission. So this is how ratchless handover happens. The next is the NTN specific mobility scenarios. In event T1, there is a timer being considered here, where handover automatically happens after timer is being hit, or the next event D1 and D2, where event D1 there the UV is moving, UV is stagnant and satellites are moving, or event D2 where the satellites are also in motion and UV is also in motion. So this is how there can be different events, so which can be solved by transparent mode characteristics, and then satellite switch without handover, and UV signaling through SIB19, which I have already covered. And next is 3GPP NTN and direct to cell, which is like 3GPP NTN, it is like government, and direct to cell, it is like opening your own government. Like 3GPP NTN, it will be followed by all the telecommunication companies, but direct to cell, it is mostly followed by Starlink, because it will experience high interference from terrestrial networks, because they'll be following their own channel, which might be used by the other 3GPP NTN telecommunication companies. So that is one disadvantage here. And with 3GPP utilization, it will integrate satellite communication into the existing mobile ecosystem, and direct to cell, it will focus on providing direct cell connectivity to standard mobile devices. 3GPP, it is compliant to 3GPP, and this is like its own company. And then 3GPP NTN, it will require chipset modem level support for release 17 and 5G advanced devices, and direct to cell, it will work with existing smartphones. And 3GPP NTN designed with interoperability in mind, and direct to cell vendor specific working with other vendors components of same ecosystem not guaranteed. It will enable seamless coverage across countries, as regulatory aspects are a part of standardization. So the coverage depends on each vendor agreement with individual countries. NTN to TN mobility aspects are standardized. Uplink, downlink interference is studied and addressed. It may experience high interference from terrestrial networks. So coverage depends on each vendor agreements with individual countries. Like Starlink provided network coverage to Ukraine during war. That is direct to cell providing. So benefits from standardized 3P features, resulting in better capacity, reliability, power control, quality of service, support for broadband voice IoT. Direct to cell, it is service quality varies and depends heavily on vendor specific design and implementation. That is the difference between 3GPP NTN and direct to cell.